Alright, yesterday we solved systems of equations that had 2 variables and 2 equations. Today we're going to have 3 variables and 3 equations. These are the ones that can be lengthy sometimes. So you got to make sure you're real careful and don't make a mistake early on, because then that shoots you in the foot for the whole rest of the problem. It's not very cool. Alright, so this first one that we're going to look at says x plus y plus z equals 2. Second one says x minus y plus 2z equals 2. And then our third equation is negative x plus 2y minus z equals 1. Alright, so we're told to solve. This is what we did yesterday with 2 equations and 2 letters, and we could choose substitution or elimination. Today we don't really have a choice. It's going to have to be elimination. Now, once we eliminate something, then we're going to use an element of the substitution, but it's going to start off as elimination. So I'm trying to take these 3 equations with 3 variables and condense it down to 2 equations with 2 variables. We did this in Algebra 2 a lot, so maybe it'll start coming back to you as we start going. To decide which variable I'm going to eliminate first, since these problems take a while sometimes, I try to decide if there's one that would be easier to eliminate. Is there one that they all have the same coefficient already? And those x's do. Look down the row of x's that we have there. We have a 1x, a 1x, and a 1x. It's negative, but I'm not worried about the negative. Okay? Look at the y's. Pay attention, Hayden Baylor. I got a 1y, a 1y, a 2y. That's not all the same. Then on my z's, I got a 1, a 2, and a 1. That's not all the same. So the x's would be the easiest one in this case to eliminate. Now sometimes you're not going to have any that have all the same. But when you do like this one with the x's, you need to take advantage of it. So what we're going to do is put any combination of the equations together in 2's. Okay, like for example, this is how I'm going to start. Maybe my marker's not cooperating. Oh, we picked a no gun there. Okay. I'm going to put those 2 together and eliminate the x's. Okay, so over here I'm going to write x plus y plus z is equal to 2. Then I'm going to write the one up underneath it. X minus y plus 2z is equal to 2. Okay, we're trying to eliminate the x's. Would it eliminate my x's if I added these equations or subtracted these equations? Good. Because x right here, what Chase said is correct. X minus x is nothing. So the rule we learned in Algebra 2 was if the letter you're eliminating, if they have the same signs, you subtract. If they have different signs, you add. So we're subtracting here. X minus x is nothing. He gone. Be careful with the signs. Y minus negative y. So how many y's? 2y. Good job. Z minus 2z. Negative 1z. Good. And then 2 minus 2. 0. Okay, that is new equation number 1. Don't lose it. Holy cow.
I need all sophomores just at first spirit day if we come to the high school lobby.
Okay, now we have to make another new equation that also gets rid of the x's. It would do us no good to get rid of the x's one time and then the y's the next time. It's got to be consistent. So for that one, we put the first and second one together. See how I drew the little braces up there on the first and second one? So now I need to get the third one in the mix. So they're both correct. You just have to decide, do you want to put the third one with the first one, or do you want to put the third one with the second one? Okay, Caitlin and Dustin both said the first one, so that's what I'm going to do here. Putting these 2 here together. So I'll have x plus y plus z is equal to 2, and negative x plus 2y minus z is equal to 1. Okay, now look at your x's. They're different signs. So to get rid of those, to make those be a 0, you got to add. X plus negative x is nothing. He gone. Y plus 2y. Now look what Caitlin and Dustin just did. This is when we get excited because we got a 2-for-1 special right here. Z plus negative z. He's also gone, isn't he? So that just leaves us with 3. That doesn't happen very often. But now it's cool that it does because we already know our y.
It's going to be 1.
It is going to be 1 divided by 3. So that saved us some time when Dustin and Caitlin picked that pair and got the 2-for-1 special. It's like a blue light special at Kmart. Now we take that y as 1, and we can plug that in our highlighted one over there to find our z, can't we?
Sure can.
So I've got 2 times my y, which is 1, which is 2 minus z. What do I do to solve that for z?
What you're going to do is you're going to add that 2.
Okay, I would subtract the 2.
Oh, subtract that.
That's what first period said. I asked them why they didn't want to add the z, and they looked at me like I was stupid. Could I have added the z there?
You wouldn't have had to take the negative.
Yep. Good, Chase. Alright, so we got z is 2. Alright, we have a y, we have a z, we're missing an x. What do you think we got to do to figure our x out? Good job. Take these 2 back to whichever original one you like. Pick any one of them you want, doesn't matter. Top one Grace said. So that's x, and I'll screw it up after I write it all. X plus y plus z is equal to 2. Let's scoot that up so everybody can see. So that's 3. So x is negative 1. Now when we did these yesterday, our answer was an ordered pair at x comma y. Now we got an ordered triple. X, y, z. When I was a little taught, that stood for examine your zipper. Somebody's pants were unzipped. You say X, Y, Z. We weren't very smart. We thought examine started with an X. So that's all I got, Dustin. We're smart.
I don't have a zipper. I can't push the button up.
Fancy.
I just pulled that truck. Strings
More strings. Not sure about that.
We're sling trucks.
No.
Let me see. No, I'm just kidding. Don't actually.
Alright, got what we need there? Okay, this next one's not going to have a 2-for-1, I don't think. 4x plus 8y plus z equals 2. Then we've got x plus 7y minus 3z is equal to negative 14. And then my last one, bless you, says 2x minus 3y plus 2z is equal to 3. Alright, got a little bit more work to do on this one. The reason I already know I got more work is look at my x's. I got a 4, 1, and a 2. None of those are the same numbers. They're all factors of 4, so I can turn them all to 4s if I need to in a little bit, right? Look at my y's. 8, 7, and negative 3. Ugh. Nothing's the same there. We're talking about maybe 56 is what maybe they'd be factors of. Look at your z's. 1, 3, and 2. They're not the same either. I could make them 6s. That wouldn't be too bad to do that, but nothing's the same. So I got to do some preliminary work to get this ready. So what we need to decide on is, do you want to try to eliminate the x's or the z's? I'm not messing with the y's.
Let's do the X first.
Okay? I like the x's too, Zane, because I could do 4s here and I could do 2s here, right? So I like that. All right, Zane's going to put the x's, so we'll let Zane decide where do you want to go first. First one with which one? Second? Third? Okay, these 2?
Yes.
All right, so to eliminate the x's on those 2, this one's already got a 4x, so I have to multiply this whole equation number 2 by 4 to get it a 4x also. Remember doing that? So that's going to get us, just rewrite the first one. 4x plus 8y plus z is equal to 2. Now we're distributing a 4 to this whole thing. 4x plus 28y minus 12z is equal to negative 56. Is that right?
Yeah.
Thank you, checker. Okay, my 4x's are same sign, so do I add or subtract? Subtract. 4x minus 4x is nothing. He gone. What's 8y minus 28y?
20Y.
Negative 20y, good. Z minus negative 12z. Say that again. 13z, good. And then 2 minus negative 56. Positive 58. 58. Alright, that's just 58. My thing's not oriented. I oriented it last period. It's still messed up. Alright, so now we got to get, that's new equation number 1. Don't lose it. Now we got to put equation 3 with one of these. Okay, don't pay attention. Which one do you want to put equation 3 with? Okay, Grace is saying this, the first and the third. That works. The first one's already got a 4x, so I'm going to leave it alone. Now she needs this one to be a 4x and it's a 2. So what's she got to multiply the whole thing by?
Everything by 2.
Attaboy, so it's 4x minus 6y plus 4z equals 6. 4x's are same signs, so what do?
Subtract.
4x plus 4x is nothing. He go. 8y minus negative 6y.
Negative 14.
Positive 14y. Z minus 4z. Negative 3z. Chase, you can put it up. And 2 minus 6. Alright, that's new equation number 2. Now, no 2 for 1 special, and this is ugly, because look at your 2 new equations. We have to put those together now to get rid of a variable. But we got a 14 and a 20 on the y's. I don't know what 14 and 20 will both go into. We've got a 3 and a 13 on the z's. That's 39, what they'll both go into. So we got to decide, do we want to make our z's be 39, or do we want to figure out what 20 and 14 will go into and make our y's be that?
Let's just do the z's.
Okay, so this one, to make that a 39, we need to multiply all of that by 3. So that gets us negative 60y plus 39z. What's 58 times 3? Somebody do that.
178 times.
58 times 3.
Yeah.
Huh?
174.
I thought he said 74, and you were agreeing with him. I was like, okay, so 174 sounds better. I like that better. All right, we got to multiply this one to make a 39 by 13. So what's 13 times 14? Say it again.
112.
112 minus. I don't think that's 112.
It's 182.
That'll mess us up. Okay, 13 times negative 3 is negative 39. And 13 times negative 4 is negative 52.
Say it again.
13 times negative 4.
Negative 52.
Alright, so now looking at that, our 39z's are different signs. So we get to add. So we're adding right here. We got to figure out what negative 60 plus 182 is. I think that's 82. No. Yeah?
Wait.
No.
122.
122. That's gone. What's 174 plus negative 52? 122, I think, isn't it?
Mm-hmm.
So we had all that ugly stuff to get us to a simple what for our y? 1. Very good. Okay?
They could have made that one. Yeah. They could just draw like, 40. Wow.
Alright, I gotta find somewhere to plug the Y in now to get another letter. And it's gonna be one of the ones, I didn't highlight because my highlighter was acting stupid. It's gonna be one of the new ones that we made. So either that one that's circled or
Let's go with the bottom.
this one. Okay, Zane wants to plug it in here, is that alright? 14 times 1 is 14. So that gets me 14 minus 3z is equal to negative 4. Subtract our 14. Negative 3z is equal to negative 18. Z is 6. Alright, we've got a Y, we've got a Z, we got to get an X. Good job. So go up there and pick out your favorite original one.
Please excuse the interruption. At this time, we need all juniors who have not voted for who's who. All juniors to go on to the junior Google Classroom page and please vote now. All juniors who have not voted. Thank you.
Alright, I wrote the second original one right here because that's what Dustin asked while she was interrupting us. So I'm going to use that one. So, actually Grace argued with him, but he has purple hair, so he won.
I made it then.
Okay, so x plus 7 times 1 minus 3 times 6 equals negative 14. So that's x minus 11. Add 11. Is that right? Checking me? Okay, so then our last step would be to write that as an ordered triple, your x, y, z. So I'll have negative 3, 1, 6. Woo!
Too much.
Fun stuff, fun stuff.
Not enough.
Are we done?
Nope. Good try though. Would it be try, whatever
We
that
got
is.
4 variables in there?
Nope, thank you, good Lord, no.
37.
I got phone.
That's all you ever want to do.
That was good.
I got mention my name. We
I got a couch, I got
Kitchen.
kitchen.
In the basketball. I got sweet tea. New balls yesterday morning. We made it from here.
Alright, these say x minus y equals 6. That's the first one. X minus y equals 6. 2y plus 5z, that's a 5. 2y plus 5z equals 1. And then 3x minus 4z equals 8. Alright, what's different on this one is we still have 3 equations and we still have 3 variables, but all 3 equations don't have all 3 variables. Okay, so that's what's different. Some people like to go ahead and rewrite it all, putting a 0 in where the variable's missing. Like for example, on the number 1, x minus y plus 0z equals 6. Some people like to go and do that. I'll do that as I need to, but I don't waste my smartboard ink on that in the beginning, so I'm not going to look at that. We got to figure out what combination of stuff we want to put together to eliminate something. Justin, put it up. So I could say, well, this one's got an x and a y. This one's got an x and a z, so I could eliminate the z's. I could put these together. I'd have to make those 20s, though. I wouldn't want to do that. I could put these together and eliminate the y's. I could put these together and eliminate the x's. So there's no one that's better than the other one. You just got to pick what you want to do and go with it.
Okay.
So anybody got an idea for me to look at to tell you if that's a good one or not?
Yeah.
1 and 3. If I went with what Dustin said there, I could eliminate my x's if I multiplied this equation by 3. Or I could eliminate my y's if I multiplied this one by 4. So that one would work either way. I'm going to multiply it by 3. We'll eliminate the x's. So I'm going to have 3x minus 3y. I need that 0 now. 0z equals 18. When I write this one, where am I going to put the 0? Which letter is it missing? Y. So it's 3x plus 0y minus 4z is equal to 8. Are we adding or subtracting here?
Yes, subtract.
3x minus 3x is nothing. He gone. Negative 3y minus 0y stays negative 3y. 0z minus negative 4z.
Plus.
Positive 4, good. And then 18 minus 8. 10. Alright, that's got a y and a z. Is there another equation that already has a y and a z so I could avoid that step and just put it with it?
Middle
Okay,
one.
Caitlin's right, good. That middle one there. Okay, so looking at the middle one, this one's got a 2y, that one's got a negative 3y. I could make those 6's. Or on the z's, this one's got a 5 and this one's got a 4. I could make those 20's. So you just need to decide.
The 6.
Okay, she said the 6's. So I'm going to multiply this one by 2. So that's negative 6y plus 8z is equal to 10. Multiply this one by 3. 6y plus 15z is equal to 3.
4 would be 20.
Yes. Grace caught that. Did y'all see that? I multiplied this one by 2, so that should be equal to 20. Good, Grace. That would have been a nightmare. Alright, 6y's are different signs, so we're adding. So negative 6y plus 6y is nothing. He gone. 8z plus 15z. Anybody else that's cursing know it? 8 plus 15 is 23. Good, Grace. And then 20 plus 3. So what's z? 1. Alright. Do we have somewhere that only has 2 variables that we could plug a z in to get another one?
Yes.
Actually got several places, don't we? We could go there to my yellow one. We could go here. We could go here. The only place we couldn't go would be the first one. So you want this one, 1, 2, or 3?
2.
2. He said 3x minus 4 times 1 is equal to 8. 3x is 12, so x is 4. Okay. We've got next, we got a z, we need a y. So pick out somewhere that has a y in it where we could solve. First one. So I got x minus y equals 6. Negative y equals 2, which means y is negative 2. X, y, z. Y'all remember doing any of these yet?
Yeah.
I don't think I ever did this.
Should have. Did you not have algebra 2 last year?
Yep.
Should have. Alright, I'm going to let you try one. Good times. Got what we need on this one?
Yeah, it is.
Alrighty, this one says 2x minus 5y plus 3z is equal to negative 1. Number 2 equation says x plus 4y minus 2z is equal to 9 times. And the number 3 equation says x minus 2y minus 4z is equal to negative 5. Alright, I want you to try that. See if you can get it. Go, go, go. Talk to your huddles, see what they got.
Okay.
Gotta try it, gotta try it. And I don't know if it was y'all, if Ms. Lamb taught y'all that, or somebody has taught y'all that before, so that you add every time. And that's fine. Yeah, you're gonna have to do the multiply step at some point here. I just say you can subtract. So, but you can do that, that's fine. Okay, that's good. Now you gotta put the first one with one of the other ones, and you'll have to multiply one of them by 2.
Wait, what is it?
Some of y'all are doing what you're supposed to be doing, let's go.
Yeah, you got all the lines. Now do we have to put these in? We did this.
If I follow, he goes to the back. Because I want to hear. Nope. No, you can sit right here.
What's the date?
Yeah. Oh, no, what you did is something that you should never do. You got rid of the different variable in both of them. Here you got rid of the z's, here you got rid of the x's. You have to get rid of the same thing in both of them, so then you put those together. So I would go back,
Do the same thing.
and I would go back and multiply this second.
Oh, yeah, Mason?
Michael, get back on track, don't let their
Alright.
failures
Alright.
discourage you.
You're not distracted.
Yeah, Michael, he's up. Watch.
Once you get one variable, you plug it back into one of the original equations,
We're
right?
not, one of the new ones you made.
I know exactly what it is. No, for real. What you put in yours.
I know.
now once you get the second one, then you do
Then, yes.
Everything that.
Now.
Please excuse the announcement. See you at the poll in the morning at 7 o'clock at the flagpole. Thank you.
They give out free donuts, so.
Good job.
Yeah, now you can make your z's be 14s. So multiply this one by 2, multiply that by 7, and go there. Alright, I'm going to go ahead. I know Caleb's still working, and I'm going to start the way I heard Caleb say he started. Then we'll go from there and let somebody decide on something else. Caleb puts in the beginning these two together because they both already had a 1x, and so he could just subtract. Okay, so x minus x is nothing. He gone 4y minus negative 2y is 6y. Negative 2z minus negative 4z is 2z. And then 9 minus negative 5 is 14. So that's one of Caleb's new equations.
Yeah.
Okay, now we got to put the first one together with one of them. And here's the mistake that Caitlin had to fix, and this is common. Okay, make sure since we got rid of the x there that that's what we get rid of again. You can't be mixing them up. So I want to put this second one. Caitlin, which one were you putting it with? The first one and the second one? Is that what you did?
Right there.
Okay, so I would need to multiply that second one by 2 now to get a 2x. So Caitlin had 2x minus 5y plus 3z is equal to negative 1. Now we're multiplying all of this one by 2. So that's 2x plus 8y minus 4z equals 18. Now those two x's are same sign, so we're subtracting again. 2x minus 2x is nothing. He gone. Negative 5y minus 8y is negative 13y. 3z minus negative 4z is 7z. And negative 1 minus 18 is negative 19. So those two new equations that I've written over there on the right are what I got to put together now, but they're not jiving yet. I got y's that are a 6 and a 13. I got z's that are a 2 and a 7.
When you do this, I'll follow along with you, and then when I go to do them, so,
Oh Lord, it means we got to practice a lot more. That's what it is.
that's
But we will.
really been my problem all my life.
Alright, I guided Caitlin to make her z's 14. Did anybody have a better idea than that? 14, good. So I'm going to multiply this first new one by 7. So that'll give me 42y plus 14z equals, is that 98? 14 times 4?
Yeah.
Thank you, thank you. And I have to multiply this one by 2. So that's negative 26y plus 14z equals negative 38.
Yep.
Now my z's are same signs. So Caitlin would subtract here. This is crazy. 42 minus negative 26 is 68. Is that right? Did I do that right?
68.
Yep, 68y. 14z minus 14z is nothing. 98 minus negative 38.
136.
136. Good, Dustin. Divide by 68. And you get y is 2. Whoa, it's moving around on me. Put it down. Put it down. Why is it not putting it down there? There it went. Oh. Okay, leave it alone. Oh. It's like
Yeah,
faint now. Alright, now we gotta plug that back in somewhere. That's a 2 with the dots all around it, just y is 2. We gotta plug that back in somewhere to get a z. So either one of those new ones that we made, the 6y or the negative 13y, I would probably just do the 6 one. Is that okay? So I'm going to have, oh shoot, I'm just going to have to go stand up there. I don't know what's moved where, anything. I'm going to have 6 times 2, so that's 12 plus 2z is equal to 14. Let me get everybody to see that. Subtract my 12. 2z is 2, so z is 1. So we got a y of 2, a z of 1. Then where do we go to find an x? Back to one of the originals, good Keston, and plug it in. Anybody got a preference? Second one Grace said, so x plus 4y minus 2z equals 9. Is that the right one?
Yeah.
Equals 9. So that's x plus 8 minus 2 equals 9. 8 minus 2 is 6. Subtract your 6 and x is 3. So your finale is 3, 2, 1. Blast off. Did you end up getting there, Caitlin? Good. Did y'all get it there? Did you get it? Good. Caleb, did you get it?
Nope,
What'd you do wrong?
I have no idea.
Oh, yeah, no. Did you get it, Michael?
I got most of it.
Good.
The parts I got done, I got done.
Good. All right. We'll pick up some more. What will lighten y'all's load a little bit, y'all will be excited to know, is we'll learn how to do that in the calculator.
Oh, man.
So that's what we'll be looking at coming up. I don't remember if that's tomorrow or not, but it's coming up.
Nah, I'm in it.